Welcome back. We're continuing with example 4 of binomial expansion. We've expanded both of our binomial terms. Now we want to subtract to arrive at our combined expression. We want to calculate 3 times 1 plus x to the power of negative 1 minus 2 times 2 minus x to the power of negative 1. And this is equal to, in the lower left-hand corner, we see that we have the first binomial of 3. Our next term is minus 3 to the power of x. Our next term is plus 3x squared. Our final term is minus 3x cubed. And we're going to subtract the expansion of the second binomial. So the first term of the second binomial is 1. The second term of the second binomial is 1/2 x, followed by 1/4 x squared, followed by 1/8 x to the power of 3. Now we distribute the minus sign, so we have within the brackets minus 1, minus 1/2 x, minus 1/4 x squared, and minus 1/8 x to the power of 3. So in combining our terms, 3 minus 1 is 2. Negative 3 minus 1/2 is minus 7/2 x. 3 minus 1/4 is plus 11/4 x squared. And negative 3 minus 1/8 is minus 25/8 x to the power of 3. Now notice that in our combined expansion, we do equate to the approximation given in requirement number 2, and we're just about done. There's a requirement number 3, which you don't see yet, but it's coming. And there it is, step 3, state the range of values of x for which the expansion is valid. That relates to step 5 of our algorithm. Evaluate interval of validity as absolute value of x term less than 1. Now we have 2 binomials and we need to evaluate each of the x terms individually. So for our first term, 3 times 1 plus x to the power of negative 1, we identified our x term as x. So here we'll evaluate the absolute value of x is less than 1. Negative 1 is less than x is less than 1. In our second binomial, 2 times 2 minus x to the power of negative 1. Remember, with our manipulation, we ended up with an x term which was negative 1/2 x. The absolute value of negative 1/2 x less than 1 simplifies to the absolute value of x is less than 2, or negative 2 is less than x is less than 2. Now at this point we have 2 ranges. In order to finalize our interval of validity, we need to identify values that satisfy both intervals. So we can set up a number line from negative 2 to positive 2. And in the case of our first interval, we'll show that interval is from negative 1 to 1, exclusive. In the case of the second interval, we go from negative 2 to 2, exclusive, and then identifying where we satisfy both requirements, both ranges, we can see that that's going to be the range negative 1 to 1. So in finalizing the evaluation of interval of validity, the expansion is valid in the range of negative 1 is less than x is less than 1. We've completed all 3 requirements of our analysis. This concludes binomial expansion example 4.